So these are examples of welded joints. Example 9.4. Problem statement is calculate the allowable axial tensile load that can be applied to the connection in figure 1922. The plates are ASTM A36 steel. The weld is 7/16 of an inch and is made using an E70 electrode. Okay, so we're given a welded joint. We're given ASTM A36 steel. We're given a fillet weld, 7/16, a leg size, and we're given an E70 electrode, and we're supposed to calculate the allowable tensile load. Okay, so therefore, this is going to be based on the strength of the weld. So we're going to use that equation. PS equals 0.212 FU times the leg size. 212, 70 is our electrode, and then 7/16. So we get 6.5 K per inch. So this equation is going to give us what the strength of the weld is per linear inch of the weld. So now what we need to do is we need to multiply that by the length of the weld to get the overall load. Okay, so we have 6 inches of weld on one side, 6 inches of weld on the other side, and then 8 inches of weld along the back side, and that gives us 20 inches. So when we multiply 6.5 by 20, we get 130 kips. That's our allowable load. This thing gets also into the example of, hey, well, these two here, they have their direction is parallel to the applied load. And in this case, it's perpendicular to the applied load. But like what we said in the presentation, we're going to count that the same. We know that it's slightly stronger on this back one right here, but what we're going to do is we're going to account for it to be all the same. Okay, so the next problem is again another lap joint. Calculate the allowable axial load that is applied to the welded connection. The plates are ASTM A36 steel. The weld is 5/16 inch fillet made using a E70 electrode. Okay, so again, we're given fillet welded connection. We're given ASTM A36 steel. We're given 5/16 fillet weld and E70 electrode. Find the allowable tensile load. The length of this weld in this case is 20 inches. So we're going to use equation 19.8. PS equals 0.212 FU times the leg size. So what we have here is 0.212 times 70 times 5/16. So we get 4.64 kip per linear inch of weld. Multiply that by 20 inches and we have 92.8 kip is our welding capacity. So while we're at it, let's also check for tensile capacity. And let's use the gross equation. So the load in the gross is the area of the gross times the tensile strength, gross. I get that from table 19.2, 21.6 for the A36 material. Okay, so I multiply that out. I get 108K. That's our tensile capacity. So therefore, the strength of the joint is based on the weld strength, and it is 92.8K. Thank you.